Hey folks, I'm Luke from Covalence and welcome back to my TypeScript tips series. Today, we're going to be demystifying another TypeScript feature, interfaces. In this video, we're going to cover what they are, how they're used, and how you can streamline your TypeScript code with them. So whether you're new to TypeScript or looking to deepen your understanding, this video hopefully has you covered. So are you ready to explore some interfaces in TypeScript? Let's go! So I have my normal sandbox here, which you can find a repository to clone down below. Start up your own TS sandbox via code sandbox, or just build your own basic TypeScript project. Nothing too fancy to it. So, TypeScript's interfaces. Yes, that's what we're talking about. An interface in TypeScript is a contract, I think is the term that's typically used, that an entity should conform to. In other words, an interface defines the syntax for classes or just objects to follow, which means it contains a declaration of methods, properties, events, which are the members of that interface. It can be used to define the shape of an object, function, class, or even a primitive. So I like to think of TypeScript interfaces as kind of like a blueprint, right? They're a blueprint for a building, and just like a blueprint describes the structure of a building, where the walls should be, how many rooms there should be, where the plumbing goes, all that fun stuff, an interface describes the structure of an object or class or blah, 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 what properties it should have, and what those properties should be, right? The purpose of them, or the primary job rather, since you can use them in different ways, is to help the static type checking process. Well, duh, Luke, that's what TypeScript does. By defining an interface, you create a new type that can help you ensure that a particular structure is followed. It can be for better code organization, more robust type checking, and again, a clear contract between different parts of your code base, right? So let's make a simple looking example here of an interface like this. Interface, and we'll call it point. It's going to represent a point on a canvas or a map of some kind that will have two particular properties: an X property, which will be of type number, and a Y property, which will be also of type number. That right there is, at the end of the day, an object that describes what I would define as a point, right? A point exists in an XY coordinate plane. That's it. So when you define an object that's supposed to conform to an interface, you ensure that that object has all the required properties with the correct types. So for example, I could write const myPoint is of type point, which points to an interface, which we've seen in my previous videos examples. When I write this type declaration, it could be primitives, but it could also now be using my interfaces, my custom values instead. So I can say, oh no, I wrote the syntax wrong. It's supposed to be an assignment value to say I need a point. And you can see there's already a red underline from our compiler saying, hey, point Y is missing and point X doesn't have a value yet, and you're not conforming to our contract of what a point is supposed to be. I'm like, oh, my bad. Let me assign a value of 5 to X and a value of 5 to, or 6 to Y or something like that. As you can see, we also get a underline here because our compiler is like, yo, dog, that's not going to work because property Y is supposed to be of type number, and you're like, oops, my bad, and there you go, how interfaces are already giving us a hand, right? So because the X and Y properties now exist and also are of type number, everything is happy in the contract that we have agreed in our code base. If I remove one of the properties, we get our compiler error back once again telling us that indeed something is awry, that, hey, your property Y must exist and must be a number, which is why we get that error there. So remember, these also, like I've been talking about in my various videos, only exist during development time for type checking. They don't generate any JavaScript code and thus have no impact on the runtime behavior of your code. This is a development tool only. Right, so one of their key roles is to serve as, well, types, right? They're not just some weird little contract I'm talking about here. They actually serve as types, and I'm using that right here in my example. That means that I can use an interface to describe the structure, the expected structure of my objects, right? And it's super powerful, and this is how it works. And I can also use it in various different ways. Let's alter this one a little bit and maybe call it a person, as I might reuse this one 3 or 4 times. We'll see. Where I have name string and maybe a property of age number like that. And we'll make a user down here. We'll have user be a type of person who will, again, I have to correct all these errors as I keep adding them here. Name will be Luke, and age will be my age, currently of 36. So we have this lovely looking object happening here. Let's go ahead and write ourselves a function called greet, and we can use them as types, meaning we can add one as a type, as a parameter to say, hey, this will be passed in a person object or a parameter called person that will conform to the contract of a person interface. So now I can come down yonder and say return hello plus person dot, and automatically this auto complete via IntelliSense via our TypeScript compiler. This is one of my favorite powerful tools about TypeScript interfaces and stuff like that, this autocomplete action we have going on here. But now I can successfully call my greet function and pass in my user, and it is all happy because user conforms to the types that I gave it here, right? So it's used to specify that as a parameter that what a person parameter should be that person type, aka the person type interface. That way, if I didn't have a name or age property, something would go wrong. So if, for example, I changed it to have something not there, then again, that is already a problem. But if I didn't strong type that, then we have the problem down here saying, hey, type user, which is just an object of property name string, is not matching what the parameter is, which is a person interface type, which is a name and age, right? So that's some really cool stuff we have right there, right? So if we happen to call the greet function with an object that doesn't have that structure, we're gonna get a TypeScript error saying you're not passing in the right object for this function to work, which is, again, a super powerful feature that I utilize all the time, even in my most simple TypeScript projects. Sometimes you'll hear stuff like this called duct typing or structural subtyping, I think is what I read. I've never heard that. I've heard duct typing before, meaning if it walks like a duck and it quacks like a duck, then it must be a duck, right? That means in TypeScript that it's the shape or structure of an object, right? That determines its type, not its name. So I have an object that has all the properties specified in my person interface over there. I can use it wherever a person is expected. So for example, just like in my user type, if I don't declare this or I don't define this as a type person, and I come down here and add a location of Alabama, for example, you'll notice that my TypeScript compiler doesn't throw any errors. It goes, well, the type of user quacks like a duck, quacks like a person, talks like a person, walks like a person, so it must be a person type. Despite this interface not having a location string value, I can still pass it successfully into my greet function because it has all the correct properties, aka duct typing or structural subtyping. Very powerful feature and very, very awesomely useful as a TypeScript feature here as well. So some other things we can include would be optional properties, meaning if I come back to strong typing this as a person type, and I add a new property here such as I can change one of my existing properties to be optional. So a cool feature of TypeScript interfaces is switching to an optional property, meaning this is now something that could exist. Adding that question mark there at the end of that property name now makes it an optional property. So I can also have additional context in terms of, I can say let greeting equal hello person name if person age is a truthy value or maybe does not equal undefined. So now person age, it knows that it is a possible of number or undefined if it's not there. But I can take greeting and concatenate onto it. You are, I don't know, person.age. Just say you are X years old. I don't care what it says. Greeting, not greet. And from there, I can now return my greeting, and I can now have my code happy with user, whether that age is there or not. So if I call user without an age, it will work just fine. There's no problem here. Or if I call it with age, there's no problem there either. So again, that's a cool thing that you can do. These optional properties are super handy when you're dealing with partial substructures or when a property is not necessary to the functioning of your code. This is one of those things where I teach my students this is a really powerful feature of interfaces to really give you a hand in how you write your code and how you can call all these, like especially passing in like configuration objects to functions. I find them incredibly useful. Something that I didn't learn for an embarrassingly large amount of time is you can also have things like this, where you can have properties that are, oh, wrong place. That's in the object. It goes up here. You can have properties that are actually going to be read-only. And again, remember, this is a development-only check. If you still write the code and say ignore the compiler errors, it will run improperly. So this read only is for type checking and development time only, not in actual runtime. What does this mean? It means that I cannot do the following. I cannot have a type person be this user object be a type person, and I've marked name as a read only property, meaning I cannot do the following. Nope, stop it. User.name equals Lukey instead of Luke. We have a TypeScript compiler error that says you cannot assign to name because it's a read-only property. This is a very, very nifty tool to know in TypeScript development process because it prevents you from making stupid mistakes on properties that you shouldn't be messing with. For example, someone's name probably shouldn't change, so if you make it a read-only property, boom, your TypeScript compiler will tell you you should not be doing that. Now I could do the same on age and have it be I can de-age myself and have no error because I marked it as, well, just an optional property, not as a read-only property. That is a very useful thing to know how to do in TypeScript interfaces that can save you some serious headache. But remember, if I ignore the TypeScript error and take this to runtime, it will reassign my name from Luke to Lukey and cause a lot of problems, right? Not only that, TypeScript interfaces can be used to define functions. So they're not limited to describing just object structures. They can also define function types in an object structure. We can type the parameters and the return type of whatever our function happens to be. So I can say interface greet function like that. It can have a parameters and a return type. It's going to return a string, and it's going to take two properties, a name string and an optional age number. So this is a type for a function now, right? So now down yonder, I can change up my code a little bit to say the following. I want greet to take a name string, age, number, like that. And I can have it do the following. I can have it return and do whatever I want here. So I can just have it return yo plus name, like that. Something stupid, doesn't really matter right here whatsoever, right? So I would do the following. Let greet be a greet function type, and then down yonder I would just simply reassign greet to be of that function type right here, like that, and voila. Just kidding, what am I missing? Oh, user needs to become user.name and user.age, and now it's all honky-dory. It's totally happy, and it's fine with the way I have the code written right here, as you can see. So that's pretty cool right there, right? We can now type a function type using an interface, which I think is pretty nifty to do as well. And this can also work, for example, like class methods or object methods and functions and things like that. So you're not only restricted to doing traditional object property values and sub-objects and sub-arrays and things like that. You can have an object that has methods on it, which would be really useful for OOP programming, or having objects that might have functions on them that you can call. You'll see this a lot in React coding as well, where this might be a function that you're passing down as a prop to a component, for example. Then finally, I want to cover indexable types. Even though this video is running longer than I wanted it to, it's fine. We're going to one-take this, folks. We have the ability to do the following. We might want to create an object that can be indexed in a certain way, meaning our examples so far have only had specific property names. But what if we have, for example, an object that will dynamically populate key and value pairs, and we don't know how many they're going to have? We can account for that in interfaces as well. We might have the following. Interface string array will have an index type of number with a value of string. This right here is how you would write a traditional array of strings, which of course you could also do the following, I know, but this is how we can index it in a custom way before I get into the next point. So I can say, let my array, which will be a string array, be assigned a string value of Luke and Percy, for example, something simple like that. It's all honky-dory, all happy, and has no issue with me. So if I write my array, nope, come on, dude. My array, I don't know why it's messing with me here. Index 0, it recognizes that that value should be a string if I happen to log it, right? So let's see. Test equals my array 0. This should be a string. Yeah, it recognizes it as a singular string because I got it from a my array index of number whose value should be a string, and we're good to go from there. But not only that, it's useful for index signatures when you're trying to implement objects with dynamic keys and properties. I mean, this is overkill for an array, but if I change this, for example, to index string, and I change this to something like let my dictionary be a new type, we'll call it a dictionary type. My dictionary, which will be of type dictionary, will be the following. Now, index string, value string lets me do the following. Let test equal testing, and maybe like name be Luke. And voila, it is all honky-dory here, where if I happen to console log, if I wanted to, from my dictionary, the key value of test, for example, it should recognize that that value will be a string, and that's all fine. The output would be testing, whereas name would be string right there, and it's all happy to go. Remember, this object syntax is like a dot notation except for dynamic string name. So this is a really powerful feature of TypeScript interfaces as well, where you have indexable types that allow you to say, hey, I'm going to have a dynamic set of keys that will be strings whose value will be strings or some other type, for example. And oh yeah, finally, I want to cover one final concept, which is extending types as well, which I think is important to know how to do with interfaces and their whole power. Go back to person interface. I should have just left it alone. I knew I shouldn't have deleted it. That's always how it goes here, though. If I have that, I can make a new interface called employee. So if we want to follow dry practices or don't repeat yourself, this is a fantastic way to do that, where I can say, I want a new interface to extend what exists on the person interface and add a department string property onto it now. So I can now have an object that is of type employee that will look for name, age, and also department. This will allow me to not have to write like individual interfaces that happen to repeat a lot of the same properties. So this is a powerful use of interfaces. You can have multiples as well, meaning I could also, I don't know, add persona, and their persona can maybe have like a function called, I don't know, breathe, that will return nothing. It'll just like do a function called breathe or something like that. And you can actually have an employee not only be a person, but also extend persona or extend multiple types by simply comma separating the types they are extending. Again, something I learned an embarrassingly long amount of time after using TypeScript. So that's a really, really, really cool feature that you can use on TypeScript interfaces. So in terms of how to use these versus type aliases, I'll cover type aliases in a separate video, and also maybe even in a third independent video, cover the difference and not pros and cons, but like use cases and differences between interfaces and type aliases. But this one's already gone on long enough. And again, I want to keep these short and to the point and not ramble on for 30 to 40 minutes like I tend to in some of my videos. So that's it for our deep dive on TypeScript interfaces. They kind of seem complex at first, but they are fundamental for writing more structured and maintainable code. So we've explored what they are, how they can shape objects and classes and things like that, how they can define function types, how can they define indexable types, and we saw how we can extend interfaces and even extend multiple interfaces if we want to. Illustrates their power here in TypeScript. So remember, experiment with the interfaces, continue your TypeScript journey, hit us up in the comments down below if you have additional questions. They're a great tool for safer, cleaner code. So if you found it helpful, give us a thumbs up, leave a comment, and don't forget to subscribe for more TypeScript tip videos.